So now that I've had a chance to talk about the various features of Java streams, some of the common operations, we visualize streams in action, and I also had a chance to kind of discuss the difference between sequential and parallel streams. Let's take a step back and evaluate Java streams. And right now, we're going to look at it from the point of view of benefits. There are, of course, a few liabilities, most obviously being you have to learn how they work, but they're actually very, very powerful abstractions. So I want to focus on the pros now. We'll come back and look at some of the cons later. So there's several key benefits that Java streams provide to programs and perhaps more importantly to programmers, developers who write the code. The particular example we're going to look at here is something that I will go through in a lot more detail when we talk about parallel streams, when we talk about completable futures, and we talk about reactive streams. I'll just summarize it right now so you get the high-level view. This is something we call the image stream gang case study, and it's a very cool way to show off and compare different concurrency and parallelism mechanisms and asynchrony mechanisms to download, transform, store, and display images that are available across the network via URLs. So the way this works, as we'll see, is you get a list of URLs you want to download. It goes ahead and downloads ones that haven't already been cached and processed earlier. And then it goes ahead and applies filters and transforms to the images to do things like red eye removal or sharpening or embossing or whatever you need to do to them. And then it takes the results and it stores them in the local file system. And ultimately, of course, you can display it either with an Android GUI or some other kind of display mechanism. So you can find this program at the link at the bottom of the slide. So that's basically what it does. So what are some benefits we get from using these approaches? Well, first, using streams makes your code a lot more concise and readable once you understand the syntax and semantics, of course. And the reason why it does that is because it really focuses on this so-called declarative paradigm that emphasizes the what. In other words, what functions to perform rather than how they're implemented. Now, obviously, there, of course, is how under the hood, but what's most important here is the what. What are we trying to do? How are we composing things together, and so on and so forth. And one of the neat things you'll see if you take a look at the image stream gang example, which we will do multiple times later in the course, is there literally no Java control flow operations in this stream. There are no loops. There are no if statements. There are no switch statements. It's all very, very clean. And one of the nice things, as you'll see with most of these examples, is you can kind of read it from top to bottom in one pass, in one fell swoop, without having to sit there and play runtime system and say, okay, we're looping, we're doing if-else statements, we're doing switches, and trying to basically play runtime system in your head. It's a lot easier to read because it's focusing on the what, not the how. Some other nice things you get from streams is this concept of flexibility and composability and flexible composition, where the functions that we're applying, which are these method references and lambda expressions and so on, are automatically connected together by the stream syntax and, of course, optimized by the stream semantics, like the water purification system. So as you can see here, for instance, the output from the filter aggregate operation is then passed as the input to the map operation after it goes ahead and gets rid of images that have already been downloaded and processed earlier. Another very important capability that you get with streams is simplified scalability. In particular, it's often, usually, absolutely trivial to parallelize the program's performance and get a speed up, of course, based on the number of cores you've got, that does not require you, the developer, to have to write any multi-threaded code whatsoever. So this is really powerful. And this is something that may or may not be apparently obvious to you at first glance until you've taken my concurrent object-oriented programming course and you see what you need to do to write this code using threads and even other thread pool mechanisms like the Java executor framework or the executor completion service and so on. So much cleaner. Basically what Java Streams does, as we'll see, is it provides a functional facade that works on top of the underlying Java object-oriented fine-grained data parallelism framework, something called the common fork join pool. And the common fork join pool, which we'll talk about later in the course, gives you a pool of worker threads that are used to process all the behaviors in a stream in parallel. And then what they also do, which is really cool, is the fork join framework automatically maps the threads in the worker pool down onto the cores in the underlying hardware. And all of that mapping and all that logic and scheduling and deciding of what things run when and all the other mechanisms required to make this work are all hidden from you, the application developer. So you just focus on writing your stream and everything else gets handled underneath the hood. So that's a really nice way to simplify scalability. And again, if you play your cards right and you have an embarrassingly parallel program, you can get tremendous speed ups without having to worry much about writing the code yourself. So that's an overview of some of the benefits that streams provide. Like I said, I will have a more detailed analysis of the pros and cons of different stream mechanisms later. But in terms of the downsides, there really aren't a whole lot. The main issue is just learning curve. And so once you kind of pop your mind around the way that the streams model works, it's actually pretty straightforward. The only other downside, I suppose, is that it turns out that there are sometimes more efficient ways of being able to write parallel code. And so streams are very convenient. They make things more concise, easier to read, easier to compose, easier to scale. But there are sometimes even more efficient ways of doing things. So later on in the course, we'll cover those things as well.